Hello, all the esteemed participants and viewers. This is me, Aryan Kumar, and today we are going to learn another crucial topic that are quantities in physics, or you can say quantities that are essential for our daily life because we normally calculate it, but we don't know what we are doing, right? So, if you are a first or a second year grader, like in your college, so this is somewhat a crucial topic for you because you will learn physics again and again, but you have to at least clear basics of it. What is physics? Like what are quantities in physics? Of course, you know physics. You just define it in a lot of terms such as nature of uh, any type of science, branch of science. Science itself is physics. There are a lot of definitions that I cannot just prescribed at the point. Okay, now what are the physical quantities? Physical quantities are somewhat a quantity that can be measured by a certain data at a point, and they are having a categorized name by huge, or you can say derived scientists that have been passed in our like history, and those as well who are working yet on this field. Now, if I simply say, they basically depend on length, maybe mass, not maybe, actually mass, time, temperature, and similarly other measurements that can be calculated is known as a physical quantity. Right, that was quite simple. Now let me just tell you about derived quantity. You can simply say it as a standardized form of a physical quantity is known as a derived quantity. Now you might ask me that what is a standardized form of like physical quantity. Let me just tell you. Do you know what is an SI? You might already know that. This, that is so-called a standardized form of any unit. Okay, units basically. And if I'm talking about units, I can include kg. I can add grams. Again, this is same for mass. Okay, I can add meter per second. Okay, I can add second. I can add Kelvin. I can add Fahrenheit, and they all are units, or you can say substitutes of physical quantities that are so called units in itself, and they have a standardized form such as 1 kg is having 1000 not kilograms, a 1 kilogram is having 1000 grams. Similarly goes for a second. A 1 second is having a 60 milliseconds, and 1 minute is having a 60 second. That's how we categorize this particular derived quantity. And if I similarly talk about fundamental quantities are basically on which the actual physics depends. Now, you might ask, what is the actual physics? That can be acceleration, that can be, you can say, luminous intensity. If you don't know this, you can just simply go through it. What is luminous intensity? What is this? What is basically heat? What is temperature? What is cool breeze, etc. I don't know. You have to just search this as a assignment. What is fundamental quantity? Any particular quantity that you don't know, such as luminous intensity, that I didn't knew till the end of my metric grade. Okay, but I right now I do. Okay, and similarly there are a lot of other strategies, or you can say other terms that are normally being used in our daily life, such as mass, time, temperature, ampere, mole, amount of substance that you are studying in chemistry as well. Now the crucial topics arise here. How to what is dimensionality? You might have already studied this on my channel or from somewhere else. What is dimension? But what if I say dimension and dimensionality is somewhat a different topic? You will be shocked, of course, uh, but they resemble themselves. They aren't completely different, not completely similar, they resemble in themselves. Now, the dimensions are defined as a direction defining fundamental quantities such as length, mass, and time. And even though you can add a lot of other fundamental quantities such as ampere, luminous intensity, i.e., okay, or potential, like any type of energy, or you can add amount of substance, mole. Similarly, temperature, that is T, or you can derive it as K and in this form, and they are simply represented by square brackets and the terms that are being calculated, such as LMT. For example, there is a formula of acceleration or speed, that is S upon T, and initially S means my acceleration, that isn't a thing of thing in this. Okay, and T is my time, and if I calculate it, my time will be T minus 1. Now how will I do that? You can just simply check the video how to form dimensionalities. You can just go and read it out on your in your book, or maybe watch a video. You can simply understand what how dimensionalities are being calculated by using a lot of several formulas. And what if I say there are a lot of formulas that are dimensionless? You might ask me, what are dimensionless formulas? Let me just type it here. Dimensionless formulas. Now you might ask me, what is dimensionless formula? Okay, sorry. Okay, yeah, so what is dimensionless formula? Now, anything that doesn't have any type of dimension is known as a dimensional formula. Now, you might say, what stupid thing you're talking with me? Now, let me just clear it to you. I have two type of angles, suppose. One is plane angle. Now, you don't know what is plane angle, and similarly goes on the other hand, there is a solid angle. Now, you might like try to guess what is this angle, what is that angle. Okay, now let me just tell you what these actually are. What is a what is a plane angle and what is a solid angle? Okay, basically anything that is being done in a two dimension is known as a plane angle. Anything that is being done in a two dimension is known as a plane angle, and similarly anything that is being done in three dimension is my solid angle. Suppose there is a circle and I have to take a radian or radius of it. I will simply try to calculate it. I will mark my radius here. I will try to calculate the arc length as well. And you guys already know, you might already have studied that my arc length is always equals to my radius, that is r, and this is my theta in here. So if you don't know this, you can just simply go through basics of the trigonometry maybe, and what is radian and all. Okay, now radius equals to arc length, that is also called s. And if I form a formula from here, that is theta equals to my arc length upon r, and that is how I form my formula right here. Now if I tell you that my s is known as arc length, and you already know arc length is type of a what type of a length, right? And similarly goes for radius. Radius isn't a mass, radius isn't a time, that is what a length as well. So if I say arc length as my length of dimension, and similarly radius as my length, there is nothing left. There is only 0. Theta equals to 0. Therefore that this is called dimensionless property. Okay, and if I talk about solid angle, as I just mentioned, this is being done in any three dimension. And let me draw any type of picture that is maybe three dimension, or we can suppose it as a three dimension picture for now. Okay, Let me just draw a circle for you at first. Okay. And if you don't know what is three-dimensional, basically volume that is being calculated into its width, into its length, and its base is known as my volume, or you can say third dimension as well. And this is so called a solid angle. And now what is a solid angle? Let me just tell that to you. Sorry for my very bad drawing, but I'm drawing it digitally, so that is how I can like provide you the performance. Okay, now this is suppose the middle of a circle, and there is any type of three-dimensional you can say cone. Okay, it can be a three-dimensional cube as well. If you don't know how to draw a cube, I can just tell you how to draw this. Okay, okay, yeah. So that is how I draw a cube right here. That can be a three-dimensional cube or three-dimensional cone as well. Now in this I have two particular thing, right? First of all, radius, you already know that. The second thing is my surface area. Okay, and this is my radius square because I have two uh, fourth and back, like back point of it. If you suppose a 3D cone, okay. Now in this picture you can only see the front of it. You cannot see the back portion of it. You can just see the fourth. Okay. And if I talk about this fourth, the similar point will be available at its back as well. That's why it is r square, and it is calculated as s upon r, as if it's moving inside and inwards to it. So you can just call it as surface area upon r square. And if I talk about r square, and that is again giving me r itself, and s is again equals to my area, and area is again equals to my length. That is the property that is only available in our fundamental quantity. And r, again I just told you, that is also calculated as l. Again they both get cancelled, and I have the only remaining answer, that is 0. Now I hope that this is clear to you. The concept of dimensionless is clear to you. Thank you for joining. That's it for today. Bye bye.